Hello everyone, I'm Francois Hogan from the Samsung AI Center in Montreal, and today I'll present a new class of visuotactile sensors that combine visual imaging with tactile sensing. And we demonstrate the sensor's ability for both multimodal object recognition and for metrology. We design a semi-transparent compliant membrane with a key feature that it can be opaque or be translucent depending on surrounding lighting conditions. By mounting the gel membrane over a camera, and keeping the interior of the sensor bright relative to the outside, the sensor can behave as a tactile sensor, allowing to visualize both the texture and the contact geometry of the object, in this case a lemon. When the lights are gradually turned off within the sensor, the gel becomes translucent and acts as a camera, allowing to visualize more clearly the shape and the color of the contacted object. This sensor is inspired by the gel site sensor, which is an optical tactile sensor that employs an opaque and reflective membrane to render a high-resolution image of the contact geometry. A key component of the gel site sensor is its reflective skin, which allows to visualize contact deformations. Unfortunately, due to its opaque nature, the reflective skin doesn't allow a camera to visualize the world external to the sensor, which could provide valuable information about the object's shape and its color. Our goal is to design a high-resolution tactile sensor as the one shown here, but with the added capability of seeing through the sensor's skin. So we design and fabricate a semi-transparent reflective membrane that can either be translucent or be opaque, depending on the surrounding lighting conditions. Similarly to how a two-way mirror works, this thin reflective paint coating can be made to be reflective by keeping one side of the glass bright while maintaining the other side dark. And by alternating these lighting conditions, the glass will appear to be a see-through window. And we use this principle to define two complementary modes of operation for the same sensor. One reflective mode by illuminating the interior of the sensor, effectively acting as a tactile sensor, and a translucent mode by keeping the interior dark, effectively acting as a camera. Here's an example of the output of the sensor when the internal lighting conditions are calibrated to visualize the visual features of the sensor. When turning the LED lights on, we can visualize the tactile features, which provide feedback about the physical interactions with the surface, such as the contact geometry, the texture, or the force. We demonstrate the ability of the sensing technology to recognize diverse objects drawn from the household domain, objects with subtle textural differences, and objects with distinctions based on metrology, such as weight. We showed the sensor's ability to differentiate diverse objects within the household domain based on their visual and their tactile information. We processed the output of the sensor using a convolutional neural network architecture, where the network takes as input the visual and tactile information that's used to predict the object identity. And we show that the multimodal information that's provided by our sensor is significantly helpful for the task of recognizing diverse objects, where the visuotactile modality outperforms a sensor that outputs the two other modalities individually. To test the sensor's ability to differentiate objects based on subtle textural differences, we consider an object classification task, where we 3D print items that have a similar visual appearance, but are to be differentiated based on their textural differences. And results show that the high-resolution accuracy of the tactile sensor captures the subtle textural differences and successfully differentiates between these 6 objects. And finally, we experimentally validate the sensitivity of our sensor by making quantitative distinctions based on objects that have different masses by classifying the liquid level within a bottle. The results show that the sensor is sensitive enough to infer these physical properties such as mass. In summary, this work presents a new visuotactile sensor that's capable of multimodal perception by using a membrane that has a controllable transparency. And we validate the ability of the sensor on a variety of object recognition tasks and showcase the sensor's ability to recognize household objects and infer their physical properties, such as mass and texture. So thank you very much, and I'll refer you to the paper for additional details. Thank you.